Hey, I'm making the video on day 2, which is going to cover arithmetic and geometric series. Day 1 last time was the sequence part. I'm trying to make it quick and brief because I'm out during one of the classes, so I'm trying to get you caught up. Last time we did sequences. Sequences is a set series of, sequence is a list of numbers. Series, on the other hand, is when we start adding the numbers of a sequence. So, for example, if I had something very basic, 1, 2, 3, 4, 5, and here's our series, if I start adding these numbers instead, now we refer to it as series. Now, since it's the sum, summation is the sign that's used to determine the sum of the numbers. You would also start noticing we would start using like S of n, which also signifies sum of the numbers of the sequence. Either or is what you will notice. Now, how does the summation part of it work? Summation basically tells you that, hey, I want to go ahead and add first 10 10 numbers of a series. So k would represent, I'm going from k equals 1 to 10, n equals 10, which means please add the first 10 numbers of the sequence. And clearly this represents the term of the sequence. So when k is 1, we automatically get a1. And then plus, since it's summation, we're using plus, then we have a2, plus a3, plus a4, and then we continue up until a10, just because this one mentioned the first 10 terms. And that's what this means. We could also have this going to infinity, which means just keep adding the numbers of the sequence until infinity. That's some of the basic notation. Let's move on. Like I said, sometimes when we restrict the number of terms to be added, that's called partial sum. If we go infinite sum, which means just keep adding the numbers of the sequence forever, that series. You would think that this actually deviates into two different types, the convergent and the divergent. We'll get to it later in the lesson. Some of the formulas that you need to be aware of, you are provided with these formulas. These three are properties, they're really not formulas. These are the formulas instead for sum of sequence. Let's quickly look at them. C is a constant number. It looks really complicated, but all it's saying is add the first n terms of the sequence, so 1 through n, where C is a constant number, and then like I said, AK is the term number. For example, actually before the example, because this is constant number, that constant number can be pulled out. So we could say that, hey, let's say A is 2, so we could say that multiply every single term of the sequence by 2. So if the first term is 1, it's like multiplied by 2. Plus, let's say the second term of the sequence is 2, it's like multiplied by 2. Third term, let's say, is 3, so multiply by 2. So C in this case is 2. What we're saying is, instead of constantly multiplying every term by 2, you could just first add the numbers 1, 2, 3 of the sequence, get the sum, and then multiply it by 2 instead. So that C can be pulled out, and that's what this means. Second property says that if you're trying to add two sequences, so this one says is first sequence, here's the second sequence. If I'm trying to add like A1 plus B1, the first two numbers of two different sequences, add those, then plus A2 plus B2, add the second terms of both the sequences, then add the third term of both the sequences. So instead of doing that, this property allows us to just simply add the numbers of the first sequence, then simply add the numbers of the second sequence, B3, B3, and so on and so forth. Once we are done adding the first one, so here's sum of AK, and then this will represent sum of BK, then we're saying we could add them individually. And similarly with subtraction. So instead of subtracting the terms individually, we could first add the first sequence, add the second sequence, and then be able to subtract them. So either or works. This just turns out to be easier. Then look at some of these formulas. The formulas have been created for us. I'm just going top to bottom to top for some reason. Here's a cubic. So we're saying if we cube every number, starting with whole numbers, and then add them, what would the sum be of the first n terms? If you take the quadratic sequence, square each number, then add them, what the formula would be, which is this. This is linear, clearly. So if we're simply adding numbers, 1, 2, 3, 4, up until n, now n could be 10, 20, 100, a million, this is the formula to simply add them. And then this is constant. So this number would be, like I said in the previous example, this could be 2. If the C is 2, then we're just saying, hey, 2 plus 2 plus 2, what would that add up to? Well, it depends on n. So if n is 20, so if we're adding the first 22s, then it's simply 2 times 20, which will be 40. And then these formulas are provided to me. So let's use some of these formulas here and let's see what's going on. If you look at the first one, this one's saying, hey, add first 5 terms of the sequence. So if k is 1, then the first term is 3. If k is 2, then the second term would be 6. If k is 3, the third term would be 9. Because it's only 5, I'm going to write them all down. 12 plus 15. So literally they're asking me to add these 5 terms. But notice this is the one that matches up with C, the C and the sequence. So the 3 can be pulled out instead of multiplying every term by 3. I could say, hey, 3 times 1 plus 2 plus 3 plus 4 plus 5. And that's the idea. Now, we cannot do this every single time. Just because this was only 5 terms, I went ahead and wrote all of them. Let's just use the formula instead. That would simply be 3 times the linear, which is sum of k 1 through 5 of k. Now this matches this matches this one right here. And don't forget the 3, and the formula would be n times n plus 1 over 2. N in this case is 5 because we're going first 5 terms. So 5 times 6 over 2, and that is 30 to 15, 45. So that's sum of the first 5 terms, k equals 1 to 5, for 3k is equal to 45. Okay, let's try the second one. This one, as you can see, is the cube one. Also, this falls under the second category here, which means I can break them up into sum k equals 1 to 10, k to the third, plus sum, that sigma turned out funny, k equals 1 to 10 of just 1. So now this one represents the k to the third, this one represents the constant. I'm going to use those two formulas. N in this case is clearly 10. So let's use this formula here. 10 times 11 over 2 whole squared plus 1 times 10. That's 5, that's 55 squared. I should have kept my calculator handy. 55 squared is 30, 25, and then plus 10, so 30, 35. The sum from k equals 1 to 10 of k to the third plus 1 is equal to 3035. Let's try the next one. As you can see, this is 3 different terms. I'm going to break them up because the property allows me to break them up. This one's quadratic, this one's linear, and this one's constant. I'll write the formal notation, 24k squared minus 7. I'm going to pull out the 7 already. 24 of k plus sum of k equals 1 to 24 of 2. Okay, use the formula for k squared, and in this case is 24, keep that in mind. So I'm using the quadratic formula. There's 24 times 25 times 24 times 2, 48, 49 over 6 minus 7 for k, using the second formula. 24 times 25 over 2, and then plus 2 times 24. And I should have, I'm just doing the math. That's 4,900. 12 times 25 is minus 2,100 plus 48. 2,100 plus 48. 2848 is what this will add up to. K equals 1 to 24 of all of k squared minus 7k plus 2. Okay, kind of got cramped, but that is the sum of that. Okay, again, I'm moving on. The series part of it, this is series again. We're still in the second lesson, so we're talking about sum, but now we're particularly talking about arithmetic series, which means the original sequence is an arithmetic sequence. We're adding or subtracting the same number, but we're trying to add them up. The thing with arithmetic is that there are two formulas to find the sum. Notice how this is now showing S of n instead of the summation sign. Same thing, it's still asking for the sum. There are two formulas to pick from. The first formula needs the first term, last term, and the number of terms. The second formula needs the number of terms, the first term, clearly the number of terms, and then D, which was referred to as the common difference. So it depends on the question. Sometimes you can use either of them, and sometimes only one comes in handy. So let's look at this question. This one's saying, hey, find the sum of first 30 terms. Find the sum of first 30 terms of this sequence. They've given me sequence. Remember, sequence is from last lesson. If I use the first formula, so I need S30, do I know n? Yes, I do. Do I know the first term, which will go here? Do I know the last term? I don't, but I can find them. Because A1 would simply be 3 times 1 plus 5. I found the first term. And the last term is 830, 95, and we have 8 and 95. So the very first formula was pretty usable. This will turn out to be 1545. That's the sum of the first 30 terms. Keep an eye on the formatting also, how it's written. Example 2, find the sum of blah, 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 blah. So I know the first term here, and I know the last term. So if I were to find the sum of, but I don't know how many terms there are. Notice how we don't know n. I know this is the first term. I know this is the last term. So I know this is A1, this is A2, this is A3, but like this is A of what? Let's find that first, because then we can use either of the formulas. How do I find that? To find that, I'm going to use the formula from last time. Like the nth term is equal to A1 of an arithmetic sequence is A1 plus n minus 1 times D. The term is 120. First term is 60. D, you can clearly tell, is 4. So from this equation, I should be able to find a number of terms. 4n minus 4, 64, and n equals 16. So this is A16. There's 16 terms in total. So I have a much better understanding of it. So I know I'm trying to find the sum of the first 16 terms. So 16 divided by 2, do I know the first term? Yes. And do I know the last term? Yes. 8 times 180 to 0, 64, 6144. So sum of these 16 terms is 1440. Again, we didn't know what n was. We didn't know how many terms there were. So I couldn't have used either of the formulas. I needed to find that n, and last lesson, which is this part, helped me find it. Moving on to example 4, given the arithmetic sequence, blah, 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 blah. The first term is given, and it's arithmetic, okay? So A1 is 5. I also know D, which is 8. Now, do I know the nth term? No. Do I know the last term? I don't. Let's see what they're asking me. They're saying find the explicit form of this sequence. So basically, they're asking me to write the formula for it, the explicit formula, which was from last lesson. This is last lesson. This is not today's lesson. Look at part B. Part B is asking for the sum of the first 40 terms. Part B is today's lesson. So to go back to last lesson, I'm like, I remember the general formula was, and you have it handy on the formula sheet. This was the general formula of arithmetic sequence. Am I able to find this? Let's see. Do I know first term? Yes. Do I know, well, I don't need to know n because I'm writing the formula. And do I know D? Yes, I do. It's 8. And there's the generic formula. That was actually easy. They gave me all the information I needed to put the formula together. Now they're saying find the sum of the first 40 terms. Again, there are two formulas. The first one was n over 2, right? n over 2, the first and the last term. The first and the last term. I still don't know the last term. Let's see if I can use the other formula. N over 2, 2a1 plus n minus 1 times d. Times d. Okay, do I know everything here? Number of terms is 40, yep. And 2 times the first term plus n is 40, so this is 39, and d is 8. Yeah, I know everything in this formula to be able to find the sum. So 20 times 39 times 8 plus 10, 322, which is equal to 6440. That is the sum of the first 40 terms of the sequence. This is an infinite sequence. It just goes on forever. They wanted me to add the first 40 terms. I think this is the last example in arithmetic series, so I'll break the video and then continue the second part with the geometric. But let me finish this last question first. And every question is different. How many terms of this sequence will be needed to get a sum of 572? N is the question. And again, this sequence goes on forever. It's forever. But how many terms will be needed to add it up to 572 is the question, okay? So it's a sum of arithmetic sequence. Again, that has two formulas. I won't be able to use the first one, so I'll use the, not A, S of n is n over 2 to a1 plus n minus 1 d. N is in question, okay? I don't know n. 2 times first term, n minus 1. D is clearly just a 2. And then I already know the sum as well. We're looking to get the sum of 572. So we know this part. From here onwards, it turns into algebra. Find n, 572. 10 plus 2n minus 2. I'm going to multiply everything by 2, so that makes 4, 14. And 2n plus 8. That's turning into quadratics. Minus 1, 1, 4, 4. Yep, that's quadratic. I'm going to divide everything by 2. 572. Calculators are available for this unit. And that's what the factoring will turn out to be. So n equals negative 26 or n equals 22. Now this is the number of terms that cannot be negative, and hence n is 22, which means the sum of the first 22 terms will exactly be 572. Now can I check it? Yeah, we can plug it back in the formula and definitely check it. All right, hope it made sense. I'm switching to geometric series in the next video. See you there.